All right. Here we go. First day of math here, a little bit of algebra review. So we're going to solve some systems by using elimination and substitution. You may have a preference on one over the other. We're going to cover both here today because some situations actually lend themselves to using one or the other. My preference would be that of elimination, but every once in a while I like to toss in some substitution. All right. So this first one here, let's dust the cobwebs off. We have negative x plus y equals 5 and x minus 5y equals negative 9. Now, I'm going to use elimination on this one because it's set up very nicely to do so. Now, with elimination, we're trying to eliminate one of the variables. So I'm going to take the negative x and the x. If you add those together, boom, gone. Now I'm going to add the y's together, combine those, and I'm going to get negative 4y equals, and then 5 and negative 9 gives me negative 4. Now, when I go to solve this, I'm going to be dividing by negative 4 and negative 4, which gives me y equals 1. Cool. Awesome. So we're halfway done. Now I'm going to take the y equals 1, take that 1, I'm going to substitute it into one of the two equations. It does not matter which one you choose. Dealer's choice. Now, this second half, the substituting back in for y, the first variable you found, is the same whether you're doing elimination or substitution. I'm going to use the first one, which is negative x plus y equals 5. I'm going to substitute 1 in. And when we substitute back in, we generally like to throw that number in parentheses, showing that it was subbed in for a variable. It's more important when you're dealing with negative coefficients or coefficients of anything. So I like to just do that as like a best practice thing. All right. So if we continue here, let's see here. I get negative x equals then 4. So x is going to equal negative 4 after I subtracted that 1 over and then divided by negative 1. Now, when we are dealing with our wonderful systems of equations, what's actually happening here is these are two equations of lines that are intersecting on the graph. So this is written as an ordered pair, negative 4, comma 1. Cool? Alrighty, negative 4, comma 1. Lovely. Wonderful. That is my final answer. We'll generally write it as an ordered pair, mainly in your algebra classes, but we'll also do that here most of the time. Let's try another example, shall we? All right. So this one here is not set up right away to use elimination or substitution. I'm going to choose, again, to use elimination on this one. And I'm going to go ahead and multiply one of these guys by this, some number or what, to get something to eliminate. I'm going to take a look at this top one. I'm going to multiply everything by a negative 1. Why am I doing that? Well, that's going to create negative 5x minus y equals 0. And now when I'm dealing with this system right here, my x's are going to cancel. I'm going to add vertically here. I'm going to get y equals 30. Already halfway done. Time to plug back in. So I'll have 5x plus 30 equals 0. I just chose the top one because it seemed easiest. Everybody's preference of easy might not be the same thing. So I get 5x equals negative 30, so x is going to equal negative 6. How are we doing so far? Are we having fun? All right. Now I'll write that as an ordered pair as we did before, negative 6, comma 30. Cool. All right. Let's move on to the next one. All right, how about for fun, we do this one using substitution. So to use substitution, what we need to do is we need to solve for one variable in terms of the other. And I'm going to choose this top one, and you'll see what I mean by that if you're not fully understanding the description I gave. So I'm going to solve for x. We're going to have x equals, and then I'm going to subtract that 4y over to the other side. So I have negative 4y plus 5. This is what x equals. I'm going to take this and I'm going to substitute it in for this x over here. So I'm going to have 8y minus 3 parentheses. Here's where those parentheses really come in handy. Negative 4y plus 5, and then that all equals 5. So now I got to do a little bit of algebra, but I only have one variable in this problem. So now I can solve. So I'm going to have 8y, and then I'm going to distribute this negative 3 to both. So that'll be what? Positive 12y minus 15 equals 5. And then I'm going to combine like terms, so I get 20y. And because I want to, I'm going to add the 15 over to the other side. Add 15. We'll add it to both sides, which cancels it here. And I get 20. Wow, this is wonderful. So I'm going to have y equals 1. And now I'm going to plug back in. And you know what's nice about substitution method is that I already have one of these equations solved for x. So I can take, and I'll use a different color now, x equals, and I can just plug in my y right there. And I don't have to do really any algebra, just evaluating it at this point. I get negative 4 plus 5, so x equals 1. So my ordered pair is 1, 1. Wonderful. We've done elimination. We've done substitution. We are rolling. Let's keep it going. Let's keep it going. A couple more examples. All right. What do we notice about this one? They're not in the same order. They're not lined up like they have been. So let's line some things up. What I like to do is have everything on the left-hand side, my variables on the left-hand side, my number on the right. So I'm going to rewrite this as 8x minus 3y equals 7. That one's good, okay? And then I'm going to write it as 10x plus 4y equals 1. Okay, so I'd rearrange that second equation, flip-flop both. All right, now let's see here. I don't see any nice way of going about this one. It's like where I just multiply one of the equations. I'm going to have to multiply both. Now, I'm going to choose the y's because the numbers are going to get a little bit, they're going to be smaller. And also, one's already negative and one is positive. So they're going to cancel out, right? Because I like to add up and down. Some people I know sometimes subtract the second one so they get them to be the same sign, but I feel like people make mistakes in that. All right. So what do I need to do in order to get my y's to cancel? What's my least common multiple? For 3 and 4, that would be 12. Well, how am I going to get 3 to be 12? I'm going to multiply all this by 4. And this one I'm going to multiply by 3. All right? Cool. So 4 times 8 is going to be 32x minus 12y equals 28. And then I'm going to have 30x plus 12y equals 3. Don't forget to distribute it with all three of them. You're really multiplying both sides of the equation, but a lot of times we write it like this. I guess this would be like proper math, but we end up just, so we don't have to write it on both sides. All right. Breaking some rules. I'm a bit of a rebel. All right. These cancel out, and I'm going to get 62x equals, and then I'm going to have, let's see here, that's 31. So it looks like x is going to end up equaling 1/2. How wonderful. Ugh, fractions. Ugh. Right? Anywho, all right, I guess it's what we're going to have to deal with here, ladies and gentlemen. All right. So I'm going to substitute this back into one of these. It really doesn't matter which one. They're both going to kind of work out in the same difficulty level. So I'll just go with the first one. If I substitute that back in, I'll use green now because green's awesome. This is a green Supreme flannel, by the way. I'll be wearing it in a few videos here as I'm recording a few in a row. All right, so I got 7 equals, and then 8 parentheses 1/2, so 8 times 1/2, minus 3y. So if I have 7 equals, and then 4 minus 3y, I'm going to subtract that 4, and I'm going to end up getting 3 equals negative 3y, so y equals negative 1. So I'm going to have 1/2, comma, negative 1. Yay, all donezo. All right, we'll do one last problem here and call it a day on this one. All right, I see a nice opportunity for some substitution here. That bottom equation is already solved for y. Let's use that to our advantage. So I'm going to have 2 parentheses x minus 7 plus x equals 4. So I'm going to distribute my 2 in, and I'll get 2x minus 14 plus x equals 4. And I'm going to have, 3x. I'm going to add the 14 over to save a little bit of time. That is not going to be, okay, here we go. If I add 14, I get 18. And then if I divide by 3, I get x equals 6. Halfway done. Let's substitute the 6 in. I've already got it ready to go over here. Y equals 6 minus 7. So y equals -1. Boom, we got them both. 6 comma -1. I like it. I love it. Bada boom, bada bing. Alrighty. Hopefully that refreshed you guys. Now you can do some practice problems on your own. Woo!